Hi everybody, my name is Max Maker and in this video I'm sharing with you the complete restoration process of this 50-year-old lathe. So 2 years ago I visited my metal supplier and he showed me this machine. It was very dirty and the paint was in a very bad state, but apart from that it looked very promising. The mechanics were moving, the ways looked in pristine condition, it was just very dirty and the paint was flaking off, but apart from that it looked very promising. It's very sturdy, very heavy, it weighs more than my car, about 3,000 kilograms, but it needed a full restoration and that's what I did this summer. So the first step was to get all of the dirt off and all of the loose paint. I tried some chemical paint strippers, but that didn't work, so most of this paint had to be scraped off. And I did this inside because the lathe was dropped off by a crane and it was still standing there 1 year later after the workshop was set up because I had no way of moving it. Here there are the gears on the inside, they look perfectly fine, it's just the outside that's really bad. And after 1 day of scraping I got most of the paint off. So I was a little bit concerned about lead in the paint, but I did some tests and I didn't find any lead, so I think this doesn't contain anything, but I was still careful while I removed this. I used respirators and a very good vacuum to vacuum everything up. So all the parts that were just bolted on, I took them off, brought them outside, and then I worked on them with one of these purple wheels. I went through 20 of these wheels in total. And these are great to remove the paint. This is the best that I found. Flappy discs, they remove metal. I don't want that. I just want to remove the paint. And wire wheels, they also work very nicely, but they're more expensive. And you always get these little wires. They fly off and they get stuck in your clothes. So you really need a leather apron or something like that. And the other problem with wire wheels is that if they just barely touch your clothing, they straight away rip it up, get caught in it, and they can really hurt your skin. So I was sanding for entire days and at the end of the day I primered everything to stop the rust from forming. The cast iron rusts in a matter of hours. And this is a filler primer. So it has some particles in it that are easy to sand down, and if you add 4 or 5 layers you have a nice thickness of filler, and then you do a little bit of sanding and all of the brush strokes, they disappear and everything becomes nice and smooth. When I got the lathe, everything that is red now was black, so I already cleaned this and now I want to clean the support. All of the surfaces on this lathe were covered in a mixture of oil and dirt, and to remove it I used brake cleaner, I also tried out oven cleaner, isopropyl alcohol and engine bay cleaner, and they all did pretty much the same. They softened up the dirt a little bit and then I could remove it mechanically with a brush or a wire brush. I also used this ultrasonic cleaner, but that didn't help a lot. Most of the parts came out just as dirty as they went in. At least they didn't look very nice afterwards. There were also a lot of tapered pins and removing them was very difficult. They just wouldn't move. I went through 2 sets of these chisels. They always break or bend off. Ultimately I got them all out, but that was really not fun. I guess it's easy to install them, but to get them out again after 50 years, nobody thought about that back in the day. But all of the ways, all of the lead screws, the bearings, everything looked to be in very good condition. It was just covered in oil and dirt and I had to clean it. I wanted to own a lathe like this for a very long time, and there are plenty of these machines on the market, but most are in very bad condition. Either they were stored outside because they take up so much space, or they were used in a workshop every day for decades, and then they're in really bad condition because the ways are run down. But this machine, I was so lucky, it must have just been standing in the shed for years because there wasn't a lot of rust and the ways are in perfect condition. There's not a single nick on here, and these are hardened ways as well. And I think once I'm done restoring all of this, it will be just as good as it was back in the day, at least precision wise. And the features are also very impressive. It has power feed on all axes, it can turn all kinds of threads with different pitches, and it also has safety features like disabling the hand cranks while it rapidly traverses. It's amazing to me how they designed this machine 60 years ago just using pencils and rulers. This is so intricate and so many parts are interlinked here. Very impressive. Even for modern standards with CAD software, this would take years to design. Yes! That wasn't that hard. This is not chamfered. That's the problem. They drilled this in place and didn't chamfer this. So after I removed most of the parts from the cross slide, I wanted to take it off and bring it outside to clean it properly and to get rid of the paint. And that was very challenging because I couldn't get it off. This plate provides oil and it stops the whole carriage from going up. And unfortunately, there's a second one of these right here. No way to get to it. No access from here. I have to take all of this off. I think I have to slide it all the way back. So I tried to get to that steel plate underneath, but to reach it, I had to move the cross slide independently from the carriage underneath. And I already had removed all of the screws holding them together. And then I discovered that there are these pins here. So by threading them and pulling on them with a screw, I could get them out quite easily. And then I could finally move the cross slide independently and get to the plate underneath. And now it was finally not attached anymore, so I could bring it outside with the forklift and remove all of the paint with the angle grinder without creating a lot of dust inside. And while I was out there, I also did a full day of cleaning other parts, like this chip pan that's going underneath. That was in very good condition, was just very, very dirty and the paint was off. And I also cleaned up a lot of these smaller parts, like this cross slide right here. So the big question with a project like this is if this is actually worth doing. And I think for this specific lathe, yes it is, because all of the mechanical parts are in such a good shape that it will be performing just as well as a new lathe would. And a new lathe of this size and with these features would cost about 20 grand. And the lathe itself costs 1.5 plus 1.5 in materials roughly and 1 month of my time. And I really just worked on this, on nothing else. So it's still less than 20 grand. So I think it will be worth it. But if you have a lathe that's in a very bad shape with a lot of wear on the ways, then it's probably not worth it because you will never achieve the same level of precision. So now that the cross slide has been dealt with, back to the carriage, and the internals of that thing look very good. I just need to get it off to clean it properly and to repaint it. And that was a real challenge. There are 4 big shafts going through the carriage and all of them terminate in bearings on both ends. That's 8 interference fits and they were all stuck properly. So I started with the only shaft that was protruding, so it was easier to reach. And while I was working on that, this bolt head flew against me. I found the bolt. This is where it's from. I sheared this off. So the lowest shaft is only there to power the main spindle on and off, and it does that by hitting a switch underneath the tailstock. But it also engages a clutch and disengages a brake in the motor gearbox. A very complicated system, and it all does that with just a single movement of the handle. So I'm trying to slide this carriage off towards the back. This one should not be engaged. These two should not be engaged. This one is engaged, but that's just turning it up and down. It's just a switch. And there's a groove here, but it stops about there, so I cannot pull it all the way off. I can also not grind the groove any further because it's on the back side. I cannot reach it, and I cannot twist it any further than this. And this whole shaft goes all the way towards the end. I mean, good luck pushing that one out to either side. I tried taking this off. Doesn't move. There's a bearing in there, and of course the bearing is stuck. I'm really out of ideas. I could cut this off and then shaft it back together again because it's not turning. I mean, it doesn't have to be perfectly concentric. It's just a switch going up and down. The lowest shaft doesn't have to be precise, so I just cut it off. But the other ones had to stay intact because they ensure accurate threads and there are big loads working on them. So I had to remove the tapered pins that hold them inside their bushings. And that was a major challenge. And I tried all kinds of methods to get them loose. Striking it with a big hammer didn't work because I couldn't hit it with a lot of force and still managed to hit it accurately at the same time. So I decided to build a custom clamp that can exert a lot of force in a localized area and do it very controlled. Something is going to break. Not sure what. I bent the tip. That's all I did. So I replaced it with a hardened piece of steel and suddenly there was a loud bang. Either the pin is gone or I've got it. Yeah! This took me all Sunday. Well, I was watching Formula 1 in between, but yes! Yes! Oh yeah. I hope this one can stay. And now it's stuck here because this groove doesn't go all the way to the back and there's a key in there and I cannot remove the key. I thought if I put it in neutral, the key would be not as engaged, but it's always engaged. So I need to remove this and I was wondering where it goes because I couldn't see in there. But then I remembered at the back there was a pulley and I already removed that. So I just have to pull it out of here and there's probably just a bearing in there. And then I noticed this wiggles. That means it's probably not connected to the rest of the shaft back there. So if I take this off, I might get this whole apparatus off. I had to cut it off. No way to get to that bearing. No way to pry on this. I can fix it later. This set was worth every penny. And if I had not cut off this shaft, was I supposed to pull it all the way towards the end? That's impossible. And with that, I could finally remove the carriage. And why did I want to do that? Just so I can clean it and paint it. So let's go back to painting. I did a little test on the headstock with the filler primer, but it was just too rough to smooth it out with filler primer alone. But just so as it happened, I removed so many components that now it was light enough again to move it outside with the forklift and the dolly. So now outside I could work on this with the angle grinder and get rid of all of the old paint and clean up all of the surfaces. And what I found underneath was a very rough casting with a lot of holes and a lot of unevenness. So I filled up all of the surfaces with epoxy putty. So this is a 2-component stuff. It's the same stuff that you use on cars. And this hardens in about a half an hour. I always waited a full day before I sanded it. And I also prepared all of the other parts. And this took days and days and days. Sanding and filling and sanding. And then I was finally able to start painting the first batch of parts. So I hung up everything in the workshop, put a little tent around it to keep the dust out, and then I painted it. First with the primer. This took about half an hour to paint all of these pieces. Very, very quick and easy and very smooth. And I also primed the whole machine outside, but I put a tent around it so the paint doesn't go everywhere. And then I went back to sanding everything perfectly smooth. Just like a car job, I wanted to get this really nice. I didn't quite achieve it, but it was much better than before. And if you do a job like this, I can recommend to get a really good vacuum with a very fine filter, because you have a lot of dust otherwise. And then finally the moment arrived that I was waiting for so long, to cover all of this ugliness underneath with a beautiful brand new color. And I'm using a 2-component paint, and this is automotive paint, so it dries in about 15 or 20 minutes. You shouldn't touch it after that time, but any dust doesn't stick to it anymore. And this is how it looked before, and now it looks like this. I'm so happy with the color and with the outcome of this. This machine will look really, really nice once I'm done with it. And from this moment on, suddenly the project was completely different. Everything was beautiful now and nice to touch, nice to work with and to look at. Before everything was dirty and grimy, but now it was just a matter of putting everything back together and improving things. Cleaning these handles was very easy. They're just bare steel, and with a wire wheel you can get rid of all of the dirt and the rust, and then they come out looking very nice again. And then I put everything back together. I replaced all of the seals and the gaskets, but there weren't many of those to begin with. Most of these shafts coming out of the gearbox had no seals whatsoever, which made the restoration process much easier because I didn't have to touch the gearbox at all. I could just leave it as it was, because working in there would have been very difficult, especially with all these stuck pins. These are the wipers for the ways, and they were made from felt and a little bit of plastic, and I just replaced them with this piece of rubber. So this is 3D printed, and I got the dimensions right straight away. And then I started working on the electrics. Here's a size comparison between the old relays and the new components. They got much more compact, and nowadays the machines are a lot safer because we have emergency stops and we have RCDs that stop the current before you get shocked. Really important stuff that I had to retrofit anyway, so I decided to redo the electrics and also to add the variable frequency drive. With that, I can digitally control the speed of the main motor, and I don't have to play with the gears so much. I can just turn a knob, and that way I can increase or decrease the speed. So this VFD costs 1,300 euros new, but I got it used for just 250 euros. And when I saw it on eBay, I thought straight away, okay, this is a sign that I should add the VFD. And nowadays all of the components can be fitted to these rails and you can swap them out very easily. So these are the new electrics. They're not as neat as the previous ones, but they're much safer, more compact, easier to maintain because everything is new and labeled and clean. And of course I can get replacement parts as well. So here's where the power is coming in, the three phases, the neutral and the ground. They go to this fuse. From here they go to the main emergency shutoff relay. This is actuated by this 24 volts power supply. So when you press the emergency button, this shuts off all these three phases. So none of this is getting power. If the power is going through, it goes to this distribution. From here it goes to the variable frequency drive. So this goes to the main motor, the big motor that powers the lathe. And we also have power going down here to the crossfeed motor. That's a much smaller motor, but it still has a motor fuse. This is how they look like. From here it goes to these two relays, one for forward, one for reverse. And this crisscross here, that will make sure that if one is powered on, the other one cannot power on, and vice versa. So from here, the power goes to here. And from here I can connect the three leads from that motor. So when you press one button, one relay activates and they're in 1, 2, 3 orientation. If you press the other button, then it's not 1, 2, 3, it's 1, 3, 2. So the motor is reversed because the windings are reversed. That's all that's to it. It's pretty simple if you know what you're doing, but I think this is much safer and much better in the long term. And the other advantage with the VFD is that I can use buttons to turn the machine on and off. So I 3D printed this test piece to make sure that I got the dimensions right for these mounts, because I had threads in there anyway that I used. And then I 3D printed this prototype to house all of those buttons. So we have an emergency stop, run forward, run backward, and the normal stop. And then I found this filament from Prusa, and this had the perfect color. And I 3D printed the final box for those buttons. And here the top layer, I added some glue to that. So this is the support, and the top layer doesn't stick to the support with the glue underneath. So it's easier to remove it because the housing is quite small and reaching in there would have been difficult. Yeah, we got a perfect color match. It's amazing that I found this material, but it's also twice the price of the normal material. And these buttons are from Schneider Electric and they are modular, so you can mix and match different features, and then you have these plastic inserts and they do the electrical switching and they just get clipped in. And the housing that I printed also has threads for these cable glands, so everything is nice and neat. And now I had beautiful buttons, and there were 2 more buttons that I had to add, and I connected them with this cable inside of this box. So this is for the power feed that goes backwards and forwards, so you can quickly traverse the carriage, and also the cross slide. It works for both. And the original switches that were in there, they were too brittle, they broke. So I 3D printed this holder and I mounted these micro switches, and that way the original function still works, but we have new electrical switches. And the best feature is this little knob that controls the spindle speed. And while I was 3D printing, I also printed this coupler for this shaft. And for safety, I added an additional ground cable at the back of the machine with this very sturdy clamp. In case the normal ground breaks, we have a backup. I also bought this digital readout from the company Sino from China, and this is an amazing piece. The equipment is very high quality, the display looks amazing, you don't see the pixels very much, and the slides are very, very nice. But mounting them was a bit of a challenge, because they have to be mounted very accurately, and of course there are no mounting holes, you have to decide for yourself how you mount this to the machine. And here at the back I started by drawing this parallel line, parallel to the slides, and then I just drilled the cast iron, which was very easy, and tapped it, and then I screwed on the mount. Luckily the casting here was already machined. I don't know why they did this, but it was, so mounting it was very easy. And I checked with this depth gauge that I was absolutely parallel, of course. So the scale was mounted to the machine, and the reed head will be mounted to the cross slide, and for that I chose this bracket. I bought it back 2 years ago for the workshop. I don't even know why I bought this. It was lying around, still packaged for a very long time. And this was the perfect piece. So I cut everything off that I didn't need about it. And then I could mount this bracket to it that was supplied with the reed head. And that way the reed head is only moving with the cross slide and everything is adjustable. So here's a little test run, and you can see you know exactly where you are down to the 100th of a millimeter. So it's very accurate. And I'm so happy that I have this, because if you don't have a readout, you have to count every rotation of the handle. And if you do a mistake, you can ruin your part very easily. And it's also easy to miscount everything, because most of the scales are measuring the radius. But you're normally interested only in the diameter. Why would I ever care about the radius? I don't know why, but all of these old machines, they measure the radius, and that just makes everything more complicated, because if you forget to double the radius, you make a mistake and you ruin your part. Finding a way to mount these scales was easy on this machine, because all the components are so big that there was enough clearance in all orientations. Here you see I just had about 2 or 3 millimeters to play with at the bottom, but that was enough. I mounted this little bracket from aluminium, and then the reed head was mounted to the lower part, and the scale is moving at the top. And the good thing is with that the cable is not moving a lot. Here I'm mounting the third scale for the cross slide, and I installed this piece of steel so it extends to the very back, because we have a long travel distance and I couldn't screw anything to the blue cover at the very back. So here there wasn't enough height, so I just rotated it sideways, and that way I can still mount it. And I covered everything up with a piece of aluminium so the chips don't get into the reed head. And here the reed head is screwed to the carriage itself, so it's not moving. That's good for the cable, so it's pretty much stationary. And to mount the display, I reused this post that was left over from the coolant tower. I'm not using coolant, because dealing with the fluid is just a hassle that I want to avoid. So now the display can be positioned wherever I want it, but I also have a second display for the VFD. And the cool thing with that is that you can take the display out of the VFD and mount it wherever you like. So I 3D printed this holder. Unfortunately, I mirrored it on the first try, so I 3D printed it again. And then I super glued it to the DRO, and it looks like it's supposed to be there, and it's at eye level and it's easy to reach. I really like that solution. And this just gets connected to the VFD with a normal internet cable. All of these cables were bundled together, and then I routed them down into the electronics compartment. And that's the electrics done. This chart is used to dial in the right settings for thread cutting, but the window was yellowed, so I replaced it, and I also repainted the frame and added new screws. And the knob to change the settings was broken, so I 3D printed a new one. I absolutely love having a 3D printer available, because parts like these would be very difficult to make otherwise, and it's just easy. I draw the drawing, I put it in a 3D printer, and it comes out perfect. With all that fixed and the dial finally closed, I could fill up with hydraulic oil. So this is just standard hydraulic oil, and the machine spun up straight away. And it's actually pumping oil into the headstock, and from there it trickles down over all the gears into the main gearbox at the very bottom. But there was an issue. It's only pumping when the spindle is running backwards. And on a lathe, the spindle is almost never running backwards, and if it is, only for a very short amount of time. So I troubleshooted this pump numerous times, and every time I took the cover off, there was a lot of oil coming out of there. So I had to clean it up, seal it back up, and it still didn't work. And at first I thought maybe the motor is spinning in the left direction, and somehow some gearing is turning the spindle in the right direction. So I was looking for that, but there's no gearing that reverses the direction of the spindle. It's just done electrically. So I think there's some kind of internal valve inside of that pump, which I cannot take off easily. So I just gave up, bought an electric pump. This is a fuel pump, and I measured the current, and I'm going to add a dedicated power supply just for this. So now the oil is flowing electrically. And with that sorted, I could work on the tool post. And first I had to modify this handle, because it was hitting the other handle. It was just the wrong shape, but it was the only one that I could find with the right dimensions for the sockets that I had. So I cut it off, then I machined a hole inside the socket, and I machined the shaft to fit inside of that socket. And with the DRO, it was very easy to dial that in to the exact diameter that I needed. And with that, I got a perfect fit, and I could weld this up. It's small jobs like these that I'm going to use this lathe for, and I'm so glad that this is finally working now. And I also used this opportunity to clean up the chuck. At first I thought I could just brush it off and clean it that way, but then I figured if I just take a tenth of a millimeter off, that won't hurt at all, and it will look beautiful again. But I couldn't machine in the middle, because there were the chuck keys and they were sticking out a little bit. I also faced up the face, because this is facing me all the time and I want to face something beautiful. And the manual of the lathe mentioned that you can also buy a 4-jaw chuck. So I looked on eBay and there it was. 50 years old, probably never used because there's not a single scratch or ding on this thing. All I had to do was to take everything apart, clean it, re-oil it again, and now it's good to go. And it fits the machine without any modifications. That's the best part. Next I went back to the 3D printer and printed this organizer for all of the tools that will normally rest on the headstock. So the chuck key, the inserts, the live center and the drill chuck holder. All of the stuff that you need all the time. It's easier to reach now and it's organized and easy to clean. I also bought a variety of cutting tools and the cutting point needs to be at the exact center of the spindle axis. But the tool post on my lathe isn't height adjustable, so you need to work with shims. So I cut permanent shims for every single tool and I screwed them underneath. For the very thin ones I also used super glue, so that the way they don't get lost and you don't have to measure anything. You can just put them in the tool holder and you can start cutting straight away. With the boring bars you still want to be able to slide them in and out, so I didn't screw them on, I just color coded them with spray paint. Next I worked on safety switches. When this cover is lifted up, you want the machine to shut down, so I installed a 3D printed collar and a end stop that gets actuated. So when the cover is lifted, the VFD will perform an emergency stop and slam on the brakes. And speaking of brakes, I want a literal brake pedal underneath the machine. This is always practical when both your hands are engaged. You can just press this and the machine will slow down. So I put a spring underneath this piece of steel and that felt good. And now I'm machining a housing for that spring and that will be welded to the piece of steel. So with drilling, always drill with a small diameter first and then go to the bigger drill. And I noticed straight away that for a job like this, I need to buy some bigger drill bits because the boring bars just barely fit inside of there. And doing that was not fun at all because the boring bar is too thin, so it vibrates a lot. And a thicker boring bar wouldn't fit, so I had to do very small cuts here and it took a long time. And I thinned it out completely. I turned this into a tube. I would have been better off to just buy a tube. Well, lesson learned for the next time, but at least the parting off worked flawlessly. I cut it almost to the middle and I did the rest on the bandsaw. Then I turned it around, faced the end to make it look nice and gave it a nice chamfer. And that was it. First job done on the lathe. And I welded this to the stainless steel of this plate. I had this left over from when I built the workshop. The weld is not beautiful, but it worked out. And then I added some hinges at the front and I spot welded them on with this electric spot welder. This is just super convenient when you're working with thin sheet metal because it's super fast. And you don't need gas, you don't need a welding helmet. You just squeeze it together, press the trigger, and you get a very nice weld spot. And they are very small, but they hold up surprisingly well. Unfortunately, it cannot reach in the middle, so I used a TIG welder for that. And I really need to sharpen my electrodes, but I haven't set up the grinder yet, so I'm not doing that at the moment. So this end stop will be normally closed, and when it gets opened by the foot, the VFD has no choice but to turn off the spindle. And the cool thing with the VFD is that everything is programmable, so I can also tell it how fast it has to slow down, or if it's just coasting down, or if it actively brakes to slow it down. And right next to it we have the main switch that switches the 3 phases plus the neutral, and above it we have a multi-purpose socket for all kinds of tools that you might use, and that socket is also RCD protected. So that's the completed machine and it's pretty much good to go now. The 2 silver buttons are for forward and reverse, and the knob on the side controls the speed, and that is super convenient because sometimes you want to go really slow and that way you don't have to change any of the gears. This handle right here turns on the automatic feed, and that is used to get a consistent feed rate when you're cutting material. The small handle below that reverses the direction. And it can also do that on the Y-axis, which is pretty amazing. For that you need to push in this plunger and then the cutter moves in and out into the material. But that is not all. When you are thread cutting, you want a fixed feed rate that matches the pitch of your thread. For that it uses the big spindle at the top, which is more accurate and has more force behind it. And what I find amazing about this, that all of these gears are somehow connected, but they always have safety included that you cannot activate 2 different feeds at the same time. And the hand cranks also get mechanically disengaged so they don't spin when they are power driven. And the last job that was left to do was to install a chip guard made from polycarbonate, because the chips that fly off are always very hot and they land on your hands and that hurts. So I cut this to size, chamfered the corners, and then I heated it up to give it a bend, but unfortunately I heated it too quickly and it created bubbles. I was just too impatient and that was very annoying. But I finished it anyway and mounted it to test it out for some time to see if I can still reach everything, and maybe I have to change the geometry anyway. So far it seems functional, but it's not as easy to reach the tool post anymore. I can reach around it, but loosening the nuts is a little bit fiddly. So maybe something that has this whole shield removable would be better in the future. And while I was testing the range of motion, I got hung up with one of the cutting tools behind the chuck guard and it broke just like that. I cannot believe this thing survived for 50 years for me to break it so easily. I think this is some kind of cast aluminium, but it's very brittle, so I just fixed it with epoxy resin and glass fibers. And with that, the lathe is finally done, and it was a long journey, but I'm still glad that I did it. This is an amazing machine and it's very functional, and I'm glad that it lives on. But I wouldn't want to restore a lathe again in my life. The cool thing is that I now have a lot more capabilities in my workshop, and that will also benefit future videos. And back in the day when I was standing in front of this machine and we were discussing the price for it, I wasn't even thinking about the money that I was spending. I was just thinking about the time that I would have to spend to finish this machine. Because I knew I didn't want a dirty lathe, I want something nice in my workshop. And yeah, I spent the time. Thanks for watching, everybody. My name is Max Maker and I make all kinds of stuff. And I hope I inspired you to make something yourself today. If you like to support these videos, please just like and subscribe.